Okay, so now we're going to talk about correlation and causation. Correlation is just a relation, okay, existing between things called phenomena or mathematical variables, so statistical, which tend to occur together in a way not expected by the basis of chance alone. Okay, that's a lot of words. What does it really mean? It means if two events are correlated, this means that when one changes, the other tends to change in a consistent manner. It's basically that they're related somehow. Okay, examples, the correlation of brain size and intelligence. They're related. One does not cause the other. Okay, researchers found a direct correlation between smoking and lung cancer. She says there's no correlation between being thin and being happy. Okay, so no correlation between being thin and being happy. Now, causation, so that's correlation. Causation means one event causes, hence the name, the other event. If you look at the word correlation, look how that root word is relation, so correlation. They are connected somehow, not necessarily one causing the other. So causation, let's go back to that. Gravity causes objects to fall downward. Okay, as you download more files onto your computer, the amount of available space decreases. One causes the other. They're not just connected. They're not just correlating, but one causes the other. Just because two events are correlated, they're linked. So correlated, thinks that they're linked, does not mean that one causes the other. And I know you're thinking, what does this have to do with math? Well, when we're looking at statistical information, we want to know if there's a correlation or if there's a causation. And if I remember right, one of the questions on the EOC practice test talks about the temperature and selling cars. So that would be a correlation, but it's not a causation. So you just have to be careful with, think through, could it be other things? And we'll get through that as we go. Okay, so examples. Research shows that the rates of violent crime and murder have been known to jump when ice cream sales do. Now think about that. Violent crime and murder jump when ice cream sales do. However, buying ice cream does not cause violence or violent crimes or murders, okay? So just think about that for a second. If there's violent crimes and murder, that goes up the same time that ice cream sales. Well, when do ice cream sales go up? In the summer. Unfortunately, violent crimes tend to go up in the summer too. Okay? Next one. The more firefighters at a fire is positively, so it goes up with the amount of damage done to the building. But the firefighters do not cause more damage. Okay? But think about it. If it's a bad fire, wouldn't there be lots of firefighters there? Okay? So that's what it means by there's a correlation, but one does not cause the other. It is very difficult to definitely say that one thing causes another. Okay, so it's hard to state if one actually does. But here are some tools you can use. If the cause is taken out, does the effect still occur to the degree that it would have if the cause was present? Could there be any causes that could contribute to the effect? And this is the one that I tend to use the most. Could there be any other things? And it kind of goes with counterexamples. Is there anything you can come up with? Counterexamples are used a lot in statistics and probability, and there's truth tables and everything. So could something else be contributing to it? That's where you just have to think for your own self. Okay, so an example. Smoking causes lung cancer. Do those who don't smoke have the chance of getting lung cancer as those? Do they have the same amount? Do they have the same chance? They don't have the same chance, okay? Could something else cause lung cancer? Yes. Are there people who get lung cancer that did not smoke? Unfortunately, yes. Okay? So that's the reason you have to realize that smoking causes lung cancer, but you can also get lung cancer without smoking. So just be careful on that. We could say there is a positive correlation, though. If you smoke, the more you smoke, as smoking increases, then your chance of lung cancer also increases. That's the reason it's a positive correlation. Now, it's not a positive situation, but it's a positive correlation. Okay. But it is not the only cause. So what are other things that cause lung cancer? Unfortunately, pollution does. Pollution can cause lung cancer. Asbestos can cause lung cancer. We also have, unfortunately, secondhand smoke. So if you are around somebody that smokes, you could also get lung cancer. And then there's other reasons that we just don't have the answers for. Okay. Decide whether or not you think the following correlations are causal relationships. Causal relationships, meaning where does one cause the other. Okay. There's a positive correlation between age and income. There's a positive. So what this is saying, as your age goes up, your income goes up. Is that causal? Is there any other reason that you could have your income go up and it's not your age? Well, yes. So this one is not causation. Not causal. Meaning it's not a causation. Okay? Because you could be very young and have a huge income. Look at, for instance, Patrick Mahomes. He's in his mid-20s, and he has a huge income. It's not because of his age, it's because of his skill. There's a positive correlation between house size and the value of the house, okay? So if you have a big house, as that house size goes up, then the value of the house goes up. That is true if I'm buying a mansion today. But what if you had a big old house? Okay, big old house. Would that have the same price? No. What if it was located in a place that wasn't safe? There's big old houses. We could even find those probably around the Kansas City area. Big houses, okay? But nobody wants to buy them because they feel that they're not safe. So a lot of things could affect it. Also, the condition of the building, of the house. So this one is not causal. It is not caused. The value of the house is not caused. So those two, one does not affect the other. There's a negative coefficient between the distance you drive. So the further that you drive, the amount of gas in your tank. Does the amount of the gas? Yeah, that one definitely. This one is causal. One does affect the other. Okay, because if you keep driving, you're going to have less gas in your tank. There's no way around that. Okay, let's look at what is to be the homework, and let's just talk about some of these. What does it mean for variables to have a causal effect? Okay, so what does it mean for variables to have a causal effect? I'll give you a second. If it's causation or it's a causal effect, it's that one event causes the other. One event causes or affects the other. For sure. Okay? What does it mean for variables to have a correlational effect? A correlational effect. That means that the two events are linked. Okay? That means that when one changes, the other changes. However, not necessarily because of one or the other. Not, however, not necessarily because the other changed. Okay? And we're going to look at some more examples of that. Okay? So, what I like to keep in mind is there any other reason that it could happen? So, as the weather gets hotter, the rate of pimples increase. So, as the weather gets hotter, that's going to happen. The rate of pimples increase. Is there any other reason that the pimples could increase? I don't know about you, but if I eat fried foods, when I was younger, when I eat fried foods or I eat the wrong kinds of food, then I could still have pimples. So this one is a correlation. And it says explain your answer. Your answer is because pimples could be from the food you eat. It doesn't have to be the weather. Okay? As you read more books, your attention span increases. This one actually is a causation. Okay, it's a causation. The more you book, the more you read, the more you just sit there and calmly read, your attention span will increase. This is a causation. One does affect the other. This one was tricky for me. As you gain weight, the amount of time you sit increases. Now, if those were reversed, it would be a causation. The more you sit, you're going to gain weight. But because they said it as you gain weight, this one is a correlation. Because as you gain weight, it could be you're gaining weight because you're eating too much food. And you could be moving a whole bunch, but you could still gain weight. Okay, do you get the idea? I want you to answer number 6. And number 7. And I want you to think about, as ice cream sales increase, so does the amount of drownings. This was a correlation. Okay? Eating ice cream sales has nothing to do with drownings. Nothing. Now, they might be linked because ice cream goes up and drownings go up. Why do drownings? Well, ice cream goes up in summer. And unfortunately, drownings go up because of people are in the water more. So that's the reason it goes up. It's still just a correlation. One does not cause the other. Okay? A recent study showed that college students were more likely to vote than their peers who were not in the school. Okay? College students were more likely to vote than their peers who were not in school. So this is saying if you go to college, you're more likely to vote than those who do not go to college. Does one cause the other, or are they just correlated? Is there a connection, or does one cause the other? This one's also a correlation. Okay? The people who don't go to school, it could be that it's because they don't go and vote because they don't have transportation. So if you can come up with any reason, then it's a correlation. Mr. Shaw noticed that there was more trash in the hallways after second hour than first hour. There's not enough evidence to say. So we don't know. We don't have a reason. It could just be for whatever reason. This one's a correlation. And I'm not writing down the explanations. I realize that. Hopefully you're coming up with your own. Number 9, you hit your sister and she cries. You hitting your sister, did it make her cry? Yeah, that's a causation. Causation. Okay, look at number 10. As the number of tattoos that a person gets increases, the number of motorcycle accidents they are involved in it also increases. What do you think? Do you know of anybody who has a tattoo that doesn't drive a motorcycle? Yep. So this was a correlation. Do you see what I did there? I looked at the beginning. Somebody has a tattoo. Do they have a motorcycle? No, they don't. So it's a correlation. Each of the following are examples of correlations. Decide whether it's positive or negative or no correlation. So what I like to do is just kind of think about the number of hours you work versus the amount of money in your bank account. So as the number of hours you work goes up, does the amount of money in your bank account go up? Yes, so this is positive. The number of hours workers receive safety training, the number of incidents on the job. So the number of hours that you receive training goes up. Does the number of accidents on the job go up? No. Hopefully it will go down. The number of jobs should go down because you're getting more training. So that should be a negative correlation. Okay, that would be a negative correlation. The number of students at Summit Lakes versus the number of dogs in St. Louis. What does the number of students at at Summit Lakes have to do with the number of dogs in Lee Summit? Nothing. If they have nothing to do with each other, then this one's a no correlation. Okay. Number 14, the number of heaters sold versus the temperature in the summer months. So am I going to sell a whole bunch if it goes up? No. So the number of heaters sold, that's going to be coming down. This is a negative. Because I'm not going to sell a lot of heaters in the summer months when it's warm. The number of rice dishes eaten versus the number of cars on 291 throughout the day. Does eating have anything to do with driving? No. Unless, of course, you're eating, which distracts from driving accidents. Yeah, but it doesn't say you're eating while you're driving. The number of calories burned goes up the amount of minutes walked. Okay, so if I walk for 5 minutes compared to 10 minutes, the more minutes I walk, don't I burn more calories? Yeah. So that would be a positive correlation. It happens to also be a positive situation, but it's a positive correlation. Okay, continuing on with correlation. Stay with me. Correlation coefficient note. So another way to determine how well a line of best fit models the data is using the correlation coefficient. You can't read that. Correlation. Well, it's right here. Correlation coefficient. Those words go right here. Okay? The correlation coefficient utilizes a lot of complex calculations. Therefore, we will not be doing this by hand. So we're not going to actually do the calculations. We won't do them. But we're going to look at the correlation coefficient that's given to us, and we're going to decide information from that. The correlation coefficient is represented by an R. The range of correlation coefficients goes from -1 all the way up to 1. Okay? These are positive correlations. It's a negative correlation. Sorry, it's a weak positive if it's between 0 and 0.5. It's a strong one the closer it gets to 1. Okay, but these are all positive this direction. If it's a negative number, okay, it's weak and then it gets stronger. It's a strong negative correlation. So let's look at these and determine what our correlation would be. The data doesn't, so if I look at this, see how they're just scattered all over? There's no connection whatsoever. No connection. So there isn't one. That's 0. The data does not show any linear relationship between X and Y, so there is a 0 correlation. Look at this one. That is really strong. Okay, let me show you, I'll show you a weak one in just a second. This is a strong correlation. That's because it's strong because it's right on the line. This model is a positive correlation. I can have a positive correlation that's weak by doing this. We can see it's going in a positive direction, but this is a weak positive correlation. This is a strong positive correlation, so it's really close to 1. This one would have a number between 0 and 1. It would be lower than 1. It's still pretty strong. You can have a wide variety, and we'll see that on the next page. Correlation coefficient here, of course, is negative, but it's a strong one. This is a strong, and it's 1. This is a negative correlation, though, but it's a strong negative. Okay? If you didn't get something, always just pause the video. Okay, so now what they're going to do is they're going to give us numbers for these, and they're going to give us pictures so we can kind of see. First off, the correlation coefficient can be between, like we already said, it can be between 0 and 1 because it's a positive. These are all positive, so they're going to be between 0 and 1. This one's fairly strong. You can definitely see that it's going in a positive direction, so that's 0.86. That's a pretty high number for a positive. And the reason is because this is closer to 1. It's a higher number. The higher the decimal, the stronger it is. So this is a strong positive correlation. This is a weak positive. Okay? These are a negative. See how these are negative? So if it's a negative, it's going to have the correlation between -1 and 0. So these are going to be between -1 and 0. The closer it is to -1, that means this is going to be strong. This one barely is negative. It's really close to not even being negative. Okay? But it's saying that it's negative, but it's a weak correlation. And we also know it's a negative because it's a negative here. We know it's weak because it's not close to 1. Okay, let's look at homework, or what we want you to at least have some more practice on. So here's a chance for us to practice what we've just been talking about as far as correlation coefficients. And this is something that the EOC expects us to kind of pay attention to too. We're going to match up which ones they are. So A lot of times it's really clear on some of them which way it's going to go. So for instance, this is a very strong negative. See how it's 1 and it's negative. So this is a strong negative. So that's G. So I go for the strong ones, and then you just play between on the other ones. Okay, so you go ahead and put in the strong positive one. A perfect positive linear. A strong positive linear. And these letters can be used more than once. Yes. Okay. Now we want a weak negative. We want no linear relationship. I'll let you cover that one. I think you got that one. No linear relationship. That one should be really, 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 really tiny. This one would qualify. This one comes close, but this one is definitely no linear relationship. There's nothing going. It's so close to 0. Okay. A weak negative. A weak negative. So that's negative. So it has to be either this one or this one. Well, it can't be that one. See how big that is? That's close to 1. So it's going to be one of these two. One of those two could be your weak negative. A moderate. Oh, wait. Moderate negative. That would be halfway. So there's a moderate negative. So that's D. Okay. I was wrong here. A strong negative would actually be E. Because it's not perfect. I didn't realize it was perfect ones. So these perfect ones are where they're ones. Okay? Perfect ones have to be ones, and then the other ones are in between. Okay, play with that. Check your answers. So here we go. Let's look at these. Let's match up which ones go with what. See how this is a strong positive? What is my largest number in a strong positive? That's C. Here, this one's kind of random, but it is positive. So it's got to either be this one or this one, but it's fairly weak. I would probably pick A, personally. This one, you can't really tell. It looks like a horizontal line, so I'm not sure if that's a positive or a negative. Anything super close to 0? Yep, that'd be B. This one's definitely a negative. It's fairly strong negative. What's my strongest negative? That's a D. You see how I did that? Okay. So try this next one on your own. I'm going to pause it. You do it, go, and then we'll compare answers. Okay, so here we go. This one's definitely a negative. So it's either going to be, is it a negative strong, negative kind of strong, negative weak? Okay, moderate. So I would probably pick D on this one, maybe even E. That's either D or F. Okay, because it's fairly strong, but you have this one, there's that outlier out there. So it's probably actually D, now that I look at it again. This one's also negative, but it's pretty strong. I'm guessing B on that one. That's really pretty strong. You can see where the line actually goes. Whoa, what the heck is this one? I'm guessing kind of a weak negative, a very weak negative. Do I have a weak negative? So that must be F. Yeah, because you can see where the line would go, like right here. See how that line would probably go about right there. So that's a weak negative. That would be an F. So there we go. And then this one, just put some plots on there. Okay, you can tell that one is very weak, whatever it is. Your smallest number, no matter positive or negative, right there. See how it's close? That's the closest one to 0. That's going to be C. Okay, you're going to do this last one. Great, good. Okay, that is the end of correlation and causation. Hopefully that helped. Thank you very much. If you have any questions, you know where to find us.